Okay, everyone. So this is actually going to be my second time recording this video because the first one ended up being like 40 minutes long. So hopefully I'll be a little bit more brief in what I want to cover. So first and most important thing to cover is that continuing the way that I am, I will not be able to reach my goal with the making, or at least getting to the second grade portion of where I want to be within like 5 videos. I think 5, the video thing isn't necessarily so as important. So I will need to, I think, change my goal, or at the very least, which is, no, okay, not at the very least, what is most important is that I am able to start treating my time with more respect. Definitely been wasting my time a little bit on things that probably shouldn't be, not really sleeping as well as that I should be, stuff like that. But in any case, the reason I bring that up and the topic of this video is that we are only done with counting, or rather I'm only done with counting, but and the reason for that is what I'll go into today. So in brief, what's most important, I think, to take away from this before we go really any further is that self-teaching is difficult so far for me in that time management is tough because you're your own boss. 2, knowing where you are making mistakes or knowing how to solve the ways that you incorrectly learn things is incredibly difficult by yourself. Of course, that is the point of this. So I've noticed that making the videos and reviewing them and stuff like that has kind of showed some glaring issues, I think. As for continuing, I'm excited to continue because I've learned quite a bit. I'm going to try to, as quickly as possible, cover some of the more fun and more challenging and frustrating things about what I have been learning. Of course, I'm not trying to teach the viewer because that would take far too long, and also I am a terrible teacher. So for somebody who's trying to teach himself something, this is not, the cards are stacked against me, let's say. And so if there's anything in your life, whether it be math or whatever, that you want to teach yourself, know that if I can do it, then a baby with a spoon and a crayon can do it. And it could be anything, I bet. They could probably learn how to shoot rockets. In any case, so the counting activities were really easy. I've got a media file with some the more important aspects of what I was learning. But as you can see here, we're still in pre-K. And we are not finished in pre-K either. We've only done counting, and there is so much more to do. There is so much more to do. I am hoping that the next video I make is going to be all of these. And the issue with that is what we get into now, is because even though it is just pre-counting and counting that I'm covering in this video, which I've learned, there's a lot. And it took, now to be fair, not forever, but it took a fair amount of time to do that. So, first things first. We'll start here. What I've learned. And here are the resources. I'll be posting the resources in the description below. So we'll start here. My number system, not my number system, our number system. The number system we use is a base 10 system. I didn't know anything about base number systems at all. I didn't know that. Binary is 2. The Babylonian numeral system, as it says here, is base 60, which we use for clocks and angles and things like that. That's really cool. Now the first speed bump of what I was learning here is that is this here. And by speed bump, I just mean that I have found it to be extremely beautiful, extremely interesting, and of course that leads to me falling into a deep rabbit hole, which is fun. It was fun. So, I watched a video, which again will be in the description, about it's called a brief summary, I think, a brief summary of number systems. And come to find out, because of, I suppose, the work of those who lived in the North African Maquis, I think is what it is, we use the symbols here that we do. They, I guess, are derived from this. That's pretty interesting. In that video, they challenged the viewer to make their own number system, their own positional number system, which was really fun. I was out on a walk with the dog outside, and okay, this is an interesting point before we get into this. I was thinking to myself, what would be a better way to... Okay, no. So with number systems, positional number systems, a 10, right? 10 here isn't what I have always thought 10 to be, right? So I've always thought 10 to be its own unique symbol. And I think that the issue with 10 being its own unique symbol is that there's a type of dissonance within that, right? Is that it doesn't have any pieces. There are no pieces to 10. It's just like, that's it by itself. But what's actually happening, because it's a positional number system here, is that this is the ones place and this is the tens place. Ones, tens, and of course this being the hundreds, etc. And what happens here is that we multiply whatever is in that position by 10. Oops. So it's by 10 to the 0th. And that here is what leads me into a deeper rabbit hole later, of which I will go into. And the 1 here is 10. We multiply 1 times 10 or whatever's in the position. It could be, if this was 3, right, this would be 3. To the first, of course, making it 30. So what's actually happening here when we look at a 10, or in this case, yeah, so not 30, 10 in this case, what's actually happening is that we have 10 plus 0 equals 10. Or if it was, we'll do 53.6. It's 50 plus 3 plus 0.6. Oops. This, of course, being 6 times 10 to the negative 1. That's so cool. That is so cool to me, and it has opened up a world of different perspectives when it comes at looking at numbers. So instead of looking at just a 1 here, or just instead of looking at 10 as its own symbol, being able to look at 10 and knowing that it's actually a dynamic set of 0 through 9. Of course, 0 through 9 all existing here in the ones place, and that's notified by that being here. Only one set is there. So if this was 2, 0, right, then we would have 2 sets of that. I think that's really cool. And maybe I'm doing this wrong. Maybe it really should be 1 through 10, but I think that gets confusing. I'm less confused for whatever reason by 0 through 9. Any case, I really like that. And so the video challenged us to make our own system. So I made one from Clover's. I was out on a walk, and I was thinking about the idea that I love the idea that a 1 can actually be 10 things, or it can be 100 things. Like this is the 1 or 2 or whatever it is. Of the 10 unique symbols that we have signifies a set underneath it, and based on its position signifies how many sets. So I was thinking it was a lot like a tree, right? And so a tree has, a bunch of leaves. I don't know what the set is, but we can call it one tree. That's one tree. But really, one tree, if it's in the this is a little bit abstract, but depending on what type of tree it is, let's say there's different types of trees, and this tree is significant in that it's all these trees are in, like, I don't know. Okay, this metaphor kind of doesn't work, but in any case, let's say it has like 30 leaves on it, so one tree is actually equal to 30. because it's in let's say it's a base 30 system. And so if we saw 2 trees, we would know that that means 60. Or like 60 or 5 pieces of fruit each. So we know that 2 trees is 10. I think that's so cool. And of course, really the whole point of that is that depending on your base is how much information you can store in one single symbol. And based on its position too. I love that. I love that way more than what we originally started with, which was, just a simple symbol, 10. And saying, okay, well, I have 2 symbols of 10. What are those together? Okay, well, I know 1 plus 1 is 2. So I guess I have to now assign this to the symbol 20. I don't know. I know that it makes less sense like that, and but that's how my brain thought of it. It didn't. It's like in the previous recording of this, I said the same way that we know. If I asked you 5 times 2, you know off the top of your head that's 10 every time. But for me, for whatever reason, it means so much more to know that 5 times 2 is 5 plus 5. And I know that we can only get to 9 starting in the ones place, because these are just ones. So that means we have an additional layover, and to represent that, it's 1, 0. But that in total, 1, 0, even if it was just 1, and we weren't looking at, that 1 is actually 10. It's actually, there's 10 little dots here, whatever you want to represent it by. And I'll get into that too. That's kind of blowing me away as well. But I love that. I love that, in a way, 5 times 2 is technically 1. Just 0 next to it. Put 0. And I love that this means that there's 0 through 9 here. It's just we wouldn't write it that way. We write it this way. That's beautiful to me, and for whatever reason, it's blowing my mind, and it's making numbers way more fun to manipulate. Maybe in ways that aren't so important, and like I said earlier, or maybe I didn't cover this earlier, but the unfortunate part about self-teaching, and I'm finding this to be true for me, is that if I latch on to an idea that's maybe necessarily not so utilitarian, let's say like I said first, if you're teaching yourself how to skateboard, let's say I've latched onto this subconscious idea that before I do an ollie, I have to bend down for a certain amount of time until I feel like I'm ready to do the ollie. Like I always have to get like at minimum like 3 or 4 seconds before I do the ollie, before I'm ready. And as you continue down the path, that might really cause a lot of trouble, because sometimes if you want to do like a trick, like a bunch of tricks at once, you don't really have time to do that. And maybe down the line that'll get sorted out, and you'll have to, but I don't want to have those habits starting off. But I don't know if that's inevitable with self-teaching. That's just one of the issues that I think has come from self-teaching, but of course that's the fun of what I'm doing. So anyways, we'll go ahead and get started here. Wow, this video is already taken long, so I'll blow right through these, or at least I'll say I'll blow right through these. But basically, this is the system that I created looking at, instead of trees, I looked at a clover, and I saw that it had 3 petals. I was like, that's awesome. I wanted to let's make a system using clovers as my numbers instead. So because it's a base 4 system, without any leaves, we'll call that a 0. A clover with 1 leaf is a 1, 2, 3, etc. But we can only have 4 because it's going to be a base 4 system. I learned that in any number system, what they use as a decimal, or what we call a decimal, because 10 mole, like 10 point. But basically, a radix point is the separator between the fraction value of your number system. And so going in here, instead of tens, right, based on its position, we have 4 to the 0, 4 to the first, 4 to the second. And so 3 times 4 to the power of 2 is 48, because it's a base 4 system. So this written out here, if all of this was gone, right, all this text here, if you knew what this was and you knew that it was a base 4 system, which I guess you could infer by there only being 4 of these, but you would know that this is 50.25. And I like this because it abstracts the idea that that numbers are in themselves, like you see, like I said, numerator value here, but it abstracts the idea that numbers in themselves are this symbol. that 10 is uniquely 1 and 0, and that's how it is. That's if you saw 10 of something, there's this inherent value of the symbol 10 as opposed to its absolute true value. I'm sure I think I read briefly about that stuff on Wikipedia, but I like that a lot. I think that's extremely beautiful. So moving on, there's a website here that I have it pulled up, Scienceline. So one of the things that I got hung up on while doing the base 10 and learning base 10 is that I didn't understand why 10 to the power of 0 is 1. I didn't understand that because if you multiply 10 times 0, it's 0. It's 0, right? So I didn't know what was actually happening. And I could be just jumping the gun here, right? Because we're still on counting, right? We haven't even made it to multiplication. And I think this is kind of one of the issues here. But, or we haven't even made it to exponents, not even multiplication. So I might be jumping way ahead. But 10 to the 0 really kind of frustrated me. I didn't understand what was going on. And what's crazy about this here is not only is there one answer or two answers, there are so many. There are in total 6 answers to the same question. And I really could only truly wrap my head around this one, the first and the second one, a little bit of the third one, but I stopped on answer 4. I couldn't even, I think both from like time and like almost exhaustion, I could not continue. And it gets crazy. I have no idea what's happening here. I'm sure if I really bit down into it, I could. But in any case, what he's explaining here is that he's going to be using, for instance, 2 to the 3rd, okay? So 2 to the 3rd is equal to 2 times 2 times 2, which is equal to 8. So basically this is like writing out 8 equals 8 equals 8. They're just different ways to write it. And I was like, okay, I agree with that. I understood that. However, the second answer here, y, for example, 2 to the 3 is 8y, because there are 8 ways to write 3 sets of numbers where the number can either be 1 or 2. This blew my mind in a way that was just intriguing, not like, whoa, so true, but I was like, why? What does that even mean? And the only thing that it's like right here is mathematics was initially developed to describe relationships between everyday quantities, and the TED Talk video that I'll put in the description explains that. A raised to the b power is that the answer represents a number of ways you can arrange sets of b. And I don't know if exponents, the whole point of exponents are sets, but here I'll just show you a little bit of the rabbit hole I fell down into with this. As you can see, this is a lot here. So what's so strange about this, uniquely here, is that this is the way that my brain envisioned these two things, right? So 2 times 2 times 2 equals 8 is the way that I saw it, is that you're taking these two, and if you want 2 versions of this, right? So absolute value 1 and 1, those plus together is 2. But now I want 2 versions of that together. So 1 and 1, 1 and 1, which is 4. And then I want 2 more versions of that. Okay, so we have 4 and 4, which is 8. But it seems like a system of copying, right? So really we have 8 copies of this. We have 4 copies of 2, 8 copies of 1, whatever you want to call it. And this, so all of these have the symbols here are not necessarily important, right? It's absolute value that determines what's happening. And I could be wrong in what I'm like describing here. But like, these could represent people. They could represent cars. They could represent elephants. It doesn't matter. But what I'm hung up on is, and which is explained here, is because differently so, when you do the set version, right, each one of these has to be uniquely different from the other, as opposed to this. These could be whatever they are, but both of these end up being 8. And so I'm wondering why. Why is that? Why is a set that's different, that's uniquely different from these? Why would it be any different? And I think that I come in conclusion to the answer down here. But to give you an idea of what I was trying to describe, right? So it's like if number 1 is Bob and number 2 is Anne, is it Bob and Ann, and then you get, now I just want 4 sets of that. So Bob and Ann, Bob and Ann, Bob and Ann, Bob and Ann. It's a weird word, but the thing is every set has an absolute value of 1, and you can see where I kind of go wrong here, at least with the copying thing. And I think why are the sets different from each other? Where one is a method of copying and the other one is string creation. So I have no idea where in my brain I've gotten the idea about copying. And I'm thinking that it's possible that I've misunderstood information that was taught to me in school when it comes to the nature of taking step processes in math, right? So when you have, I think they're called ratios, where you want to find, like, it's like you start with the number 64 and you end up with like 2 to the square root of 3, or so. I don't know if that's right, but it's like they create these like maps, like the root maps or something, where it's like 2 times 5, 2 times whatever, 2 times blah, and then you have 3 2s, so you write 3 to the 2. And it's this issue of breaking things up into steps, I think, that's like confused me, because what's actually happening is when you write it out like this, 2 times 2 times 2, it's actually, I mean, it's the exact same as just writing 2 to the third. And of course 2 to the third is the exact same as writing 8. It's not really it's not an operation, I don't think. Like, is it inherent that the 8 is an operation? I guess, right? Because its positional system is 8 times 10 to the first. Does that mean that 8 is really, does that mean it's intrinsically true that every number is just a set? Right? But in this sense, because it's in the ones place, right, the sets that it would exist is, how many sets can you write where you only use the numbers 1 through 8 and each one has to be differently? But you only use one number, right? You would only be able to use 8. I don't know. It's like, I don't know if sets are what are the true deep understanding of numbers, and I really wanted to get further into that, and I might have to do some more research. I might have to make like a post on the internet, but in any case, my final question here really being like, is there really a difference between what is the difference between copying, right? So it's a copy, this is 2 copies of this is 4 copies of this, or 2 copies of that. Or, you know, it's 4 copies of 1, 2 copies. It's like, is that important when it comes to, oh my goodness. Oops. I wonder if I can find it again. Where did it go? Any case, so I don't know if that's, like, important in programming or what. Whew, that was a long explanation. Like I said, this is a lot, and we've even just started on counting. I really want to know. I feel like it's so important for me to know why numbers are what they are. And I don't know if I fully answered that question yet. And I feel like I probably should have. But, well, continuing here. So, this list of vocabulary learned is basically just a list of Wikipedia articles, essentially. But, so, moving on to Khan Academy, and I'm taking a bunch of screenshots here, and just kind of illustrate my kind of frustration with numbers a little bit, or at least how I've learned numbers or whatever. So, I didn't label this one like I labeled the others, but basically what's happening is that, obviously, right, they want number 2, right, because this is the number line between 1 and 3, but it says count the flowers. Right, and to me, this seems like a separate entity between this. If it was really 1, 2, and 3, wouldn't it be 1 flower and then 2 flowers caught on top of each other, and then 3 flowers on top of each other to illustrate a number line? Or like, you know, you would cover up these 2 if it was 3 to leave this. It's just one of the pieces of frustration that I have, right? Because if this was true for how much they were worth, right? So then wouldn't the answer be? If this was worth 1, and this is worth 3, and this is like an indeterminate amount, in total it would be like 4 plus whatever in the box. It's like, I'm so confused when it comes to that kind of stuff. Obviously I know the answer straight off the bat, because maybe the way it's been taught to me. But I just have a little bit of an issue with that. 1, 2, and 3. Count the flowers, I get that. But wouldn't it just be a box where you just need to answer 3? The number line thing here, I get that they each have a unique absolute value of 1, but that's only, I guess because it's illustrated right here, that's implied to be true for this, but on top of that, you're also adding to, I guess, like the tally of the base 10. It just seems confusing to me. Maybe it's just not confusing to little kids, and because I'm not a little kid, it's, just being ridiculous. But, and I won't have a bunch of these like crazy things any more so than this. I think there's only a couple more, but like in this instance right here, like a kind of similar issue that I'm having is that, and I drew on top of it to kind of illustrate what I mean, is that not only like in the first thing when I was telling you, right, is where they where a sense that 10 is a unique symbol to itself, and that somehow we must know that there are 100 unique symbols because they're kind of each in their own individual box. Oops, let's get out of here like that. To me, that's a little bit frustrating, and on top of that, this, like, what would you call, if you were to look at this from a base 10 perspective, and maybe I'm even misunderstanding the base 10 perspective, but like, what would you call 70? Would it be the 7th 10 in the way that they've kind of illustrated it here, right? And maybe this is like, what is it, like Gestalt psychology, where you read into the order of things, and because these are kind of ordered in a way that's, this box shape, you can read into any type of like imaginary line that you want, right? So like all the 6s are here. I don't know, it just seems strange to me that you would think that 15 contains, that 15 is on the 20th, that is in the 20 number line or something. Like, is it, like, would you call 15, I think I say it here best, right? It's like, would you call this the 7th 10 minus 3? I know that it's 67, I get that, right? But 60's here, and everything that's contained in 60 is here, or at least, or is it supposed to be ordered like this? Or is it ordered by the first number behind it? Obviously, when we're talking about it, 61, 62, all that. I don't know, it's just, this is wrong, whatever I wrote there, but it's just strange to me. And I'm not sure really why it bothers me, and maybe somebody can give me an answer on that. Continuing though. Okay, so what I explained the first time I recorded this is, most people wouldn't understanding base 10 make this easier so you don't have to do addition. And again, this is me trying to figure out a better way to understand and to see numbers, to make it easier. And I guess most people would just say, oh, well, I know that 19, and because we're in an ordered number line, right, that's why they would show you these beforehand, so that to know that we're, we're adding 1 to the count, right? So they know that, oh, well, we're adding 1 to the count, it's 19, I know what comes after 19 is 20, right? That it comes after idea, that here's a symbol that arrives because of this symbol and its previous. That to me seems like a strange dissonance, when for me it seems much easier to know that 9 is the last unique symbol, and we're adding 1, right? And so that means we must move to the second position. It's already a 1, so now it's 120, 120. And me explaining it like that makes it seem like it's far worse to do that way. And it probably is. I don't know if it is. Maybe it's just easier, like I said earlier, 5 times 2 is 10. Maybe it's just easier to just know that, to just remember that. But it doesn't seem like you're accessing an understanding behind it to me. Oh, well, what comes after 19 is 20. I don't know. And I think that's the last one of me complaining, and the rest of them are me saying that this is cool. And you'll begin to see too that as you can see here, right, is they show you numbers in a vastly different way a lot of different times, probably for people like me who can only understand things if they're visually presented in a certain way or whatever. Like, this is cool for me, right? So, and like, this is what I was telling you about, like the efficiency, right? So I understand that we're in the tens place, Why do I understand? Well, 10 frames, right? So each set contains 10 items. So that means because it's in a set, right? And it even separates them for you because it's in a set. 1, 2, 3, 4, 5, 6, 7, 8 is so much easier than going 77, 78, 79, 80, counting them each individually. Right? It's just what you're actually doing here is basically like multiplication, right? And let's say I was doing some math in my head, trying this kind of out earlier, is that if you were to think of, one set of 8, you could think of this as one set, right? And that's how you get into the idea of what things are divisible by. So if it was, let's say 160, right? 8 plus 8, 16. Because you just know that. No. Right, but we know that if we wanted 2 of these, if you could consider the box around my cursor here one set. Well, I know that one set is 160. I think that's so much easier. I don't know. Or you could say, 80. I know that, whatever. And I don't know it too. I don't know enough myself. And it's like I have to fight my brain to really get to a place where I'm understanding it. And it's hard to articulate as well. But I really liked this one. Of course they're already in the frames, so you only have to drag 4. I love that. 1, 2, 3, 4. And guess how much you've just made? 40. I mean, it's still really just 4 with the little next to it. It really doesn't matter what's in the set, right? And that's what I love about it. Because I want the number system to do the work for me. I want the positional-based system to do all the work for me. And I guess I'm trying to use that to my best benefit in the same way here, right? Instead of having for me to count out the individual dots, you just pop, there's 4 of them. And I guess, again, that's what multiplication division is. And maybe it's like I'm trying to invent multiplication or whatever, but I don't know. These are a little bit more abstract. I like this better than symbol counting, right? So we know that we assign, it's asking for pairs, right? So we know that we assign 1 and 1. But I like the idea that too, if I wanted to know how many pairs of pairs there are, right? The answer would be 1. Which box has 15 turtles? This is showing the frustration of urinary count. All right. I'm not even sure if that's how it's spelled, but right, so if you had to sit here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, which I'm sure a lot of little kids are doing, right? Because this is for tiny children. I'm obviously not a child, and that's probably why I'm finding frustration in it. But I love I'm finding frustration differently, but I love the idea that it introduces the frustration here. It's like there's so many turtles that I have to count, right? First I've come here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's like, well, wasn't enough. Let's try this one. Right, and then eventually they'll be excited to know that all they have to do is do 1, 2, 3, 4, 5. Oh, well, there's 3 sets of 5, 15, right? That's so much more easier. But again, I don't know. This is supposed to be just counting, and I'm probably just getting ahead of myself. This is interesting for different aspects, right? So we count the most, and I love this, right? So they're all in the same line, unlike the flowers beforehand, right? So let's say you only learned because of the flowers beforehand, right? It seems strange to me. You might be like 1, 2, 3, 4. Oh, but we want different ones. Okay, 1 fox. Okay, 2 fox. But you have to keep track that there's 2 here. Add more. Okay, I'm keeping track that there's 3 here. I don't know. That part I don't like, but 1, 2, 3, 4, 5, 6. It's like, oh, okay, great. Well, 5. Oh my lord, yeah, I still need to learn counting. In any case, I thought that was cool, that they're on the same line, and they all have the same value, but what separates them is an arbitrary thing, that they're foxes, they look different, whatever. I thought that was cool. This is cool too, transitive property, I like this as well, right? So John isn't really a value, right? I can't write John on a number line and somebody know what that is, but it's cool because in this instance, I have to assign a number to John. And then not only that, I have to assign another number to Ping, and then I have to put those 2 values next to each other, which are transitive, you know, because I've just applied that arbitrary value, John and Ping, but now I have to I have to decide which one is fewer. I like that. I think that's a really cool thing to do, like straight off the bat with counting. I think that's crazy that kids are just like on it like that. They just know what to do. Maybe they don't, but I don't know. Yeah, I don't think that's all of them, but that's enough of that. I think this video is already like 30 minutes again. Maybe that's just what it's gonna end up being. But as you can see, just doing counting and already so much. Already caught in the weeds, if you want to think of it that way. Already kind of bogged down by a lot of stuff, but I'm still having fun. It's just tough to kind of pace myself in that way, and I think that's something that I need to start working on. And so maybe my next video won't even be counting. It'll be what I've done to best change the way that I go through this, because as you can see, just early math, right? And we have to go, I wanted to do this by the end of October, still just on early math, just finished the first part of early math, and we have to do these. I don't know how I'm going to decide what is a good quantity of things to work on before I decide to move to the next area, and how to know that I've understood it in a way that's good for me. That's really kind of up in the air. And again, maybe this is what's going to be the biggest challenge of Tutorial Island. Funnily enough, it isn't. Hopefully, it won't be this stuff. But I had this much, discourse on just counting. I mean, I'm barely even counting on numerators on the number system, and we haven't even begun to do like operations really. Yep. Alrighty, guys. Well, thank you for joining me in this video, and hope to see you in the next one. Bye.